Hello friends, this is lesson 9 of NLP, Natural Language Processing. In today's lesson we are going to cover the following topics. First we'll be discussing text preprocessing, and then text vectorization and transformation, and then we have frequency vectorization, one-hot encoding or vectorization, and then we have term frequency and verse document frequency or TF-IDF vectorization. Now let's start with the first topic called text preprocessing. So what is this text preprocessing? Text preprocessing is the first step to transform the raw text into a form which is ready for computation in modeling. This is very much important, friends, while we are processing the text, because the text we are reading from the disk or from the web, that is considered as a raw text, and the raw text is not ready for computation. It is not ready for modeling. So what we have to do, the first step is to clean the text and to do some certain steps on the text and normalize the text, and that is called text preprocessing. So here you see, unfortunately, any text or corpus what we are reading is called raw text is completely unusable for analytics without significant preprocessing or compression. So the raw text what we are reading from the web or from the disk, that is not ready for analysis. It is not ready for computation. The model does not work on that because the model needs quantitative values, not qualitative values. It should be converted like to a form which will be ready for computations and also modeling, right? So this is called text preprocessing. Now before text vectorization, we should load the text and normalize the text. These two steps are there before vectorization. So first of all, we will be normalizing the text. So what are the steps in normalization? These are the steps. First we will be loading the text and then converting the text into lowercase. Why we are doing this? To remove the distinction between uppercase and lowercase. This we discussed in previous lectures, because the word like here we have a and we have small a, they are considered as the two tokens, but if they are both changed to lowercase, then we will be having a single token a, right? So for removing the distinction between uppercase and lowercase, we will be all converting the text into lowercase, and then stripping the punctuations, removing the punctuations. If there is a period is there, question mark is there, exclamation is there, @ symbol, these things should be removed from that. And then now the text is ready for tokenization, means splitting the text into smallest individual units. That is called tokenization, right? And then we will be applying stemming or lemmatization. And you know the difference between stemming and lemmatization. Here the word will be converted into root. The root may be meaningful or may not be meaningful, but here the root is always meaningful, right? Now let's see here, the second step is vectorization. As we discussed, machine learning algorithms operate on quantitative values, means numeric values or data, expecting input as a two-dimensional array where the rows or instances and columns are considered as features or predictors, or we call it as an input for the model, right? So first of all, we will be converting the text into numbers or quantitative values. If it is not converted to numbers, because these machines or algorithms works only on numeric data, so it should be in the form of numbers. Then it will be converted into two-dimensional array where the rows are considered as instances and columns are predictors or features. In order to perform machine learning on text, we need to transform the documents into something called vector representation. Then we can apply the numeric machine learning. For example, now let's see here, you will better understand, friends. If we consider the same example, the man took the book, right? This is a simple sentence, and now here the first step is to tokenize it. Now they are tokenized like this, split it into tokens. The second step is vectorization. They are converted into vectors. Now you see the vectors. What do we have? We have the numbers here, right? These are the numbers. Like that, the article is repeated 2 times, and this one is repeated once, this one is also repeated once. Now they are converted into numbers. Now it is ready for computation and it is ready for modeling. So the process is called vectorization or feature extraction, right? And we have different types of vectorization, friends. Some of them we'll consider here. The first type is called frequency vectorization. If it is frequency vectorization, so how can we vectorize here the text? The simplest vector encoding model is to simply fill the vector with the frequency of each word as it appears in the document. How many times a word appear in the document? So that number is called frequency of the word. For example, here this is the sentence. The man took the book. How many times that article is repeated? 2 times. So this 2 is the frequency of this word. And the process is called as frequency vectorization. 1 is the frequency of this word and 1 is the frequency of this word. And like that, for example, if it is repeated 3 times, we will be having 3 here. If this is repeated 6 times, then you will be having 6 here. So that 6 is nothing but the frequency of the word, like this. And that is called frequency vectorization. How many times? The frequency of each word as it appears in the document. I hope you understood this definition. And then we have another type of vectorization called one-hot encoding. So let's see what is the difference between one-hot and frequency vectorization. So in one-hot, what do we have? It is a Boolean vector encoding method. Boolean means 0, 1, true or false, that marks a particular vector index with a value of true, means 1, if the token exists in the document. If the word is there in the document, then that will be considered as 1, true. If it is not there, so it means false or 0. Now again, we see that the text is converted into numbers. The numbers are binary 0, 1. So that is why it is called one-hot encoding. So one-hot encoding reduces the imbalance issue of the distribution of tokens. We will be having only 1 and 0. But in frequency, we will be having more numbers because a word may be repeated several times. So that several times the number is called the frequency. But here we have only 1 and 0. So see here, these are the tokens. And here we have this one, that it is repeated once here, it is there in the document, so we have 1 here. The girl is not there, so we will be having 0. You don't consider this, the vector is this one, the actual vector is this one. So if you consider this is the actual vector, so girl is not there, it will be 0, right? And then what do we have here? Token. And token is there, it is 1, that is 1, and book is 1. And frequency, this the and this the, they will be both combined and will be having 2 there. That's called frequency. But here we'll be having only 1 if it is there, if it is not there, 0. Then we have another type of vectorization called term frequency inverse document frequency vectorization, or TF-IDF. Right here, what do we have? We will be considering term frequency and document frequency, right? These two are so much important. So what do you mean by term frequency? Term frequency means the frequency of the word T and the document D. So for example, the whole thing, like this is a document, right? What is the frequency of the article, this one? How many times this the is repeated within this document? So that is nothing but term frequency, the frequency of a word T in the document D. For example, we have 3 documents or 4 documents. You consider 3 documents here. So in first document, how many times this one is repeated, right? And that is called term frequency. It is very easy for counting how many times it is repeated. Just we'll be using predefined function count, and that is returning the term frequency for us. And then we have the document frequency. The document frequency means the total number of times the word T appears in the whole collection in any document. Like we have 3 documents. In single document, if you are searching for this, that is called term frequency. If in all the documents you want to find the frequency of this, that will be considered as another frequency called document frequency. For example, in first document this one is repeated 5 times, but in second document it is repeated 2 times, then we got 7. In third document it is repeated once, then the frequency for this will be 8, right? In whole documents, that will be considered as a document frequency. And then we go for inverse document frequency. How it is calculated? It is defined using this fraction, friends. N divided by DFT. So what is N? N is the total number of documents what do we have in the whole corpora. How many documents are there? 3, 4, 5 documents are there. That N represents the number of documents in the collection, right? And you know that DF is document frequency and this one is T, term frequency. How do we calculate the IDF, inverse document frequency? It is equal to log base 10 N divided by document frequency of term frequency. Let's have an example. You will better understand seeing this example. So consider the word the, this article the word in the given text, the man took the book. How many times it is repeated? So we have a single document. So you consider this sentence as a one document. So we have only one document. Let me first tokenize. This is the tokenization, and then vectorization. This is the vectorization. So we have how many documents are there? Only one document we have, right? And now let's see and calculate the document frequency. That is equal to 1 into 2. 2 is term frequency. How many times it is repeated? 2 times. And 1 means in one document. If you have 3 documents, then you have to put here 3. Once it is repeated in one document, 2 times it is repeated in second document, 3 times it is repeated in 4 documents. So you count all those things and put here, and how many documents you have, you put it here, and after that you will be getting DF. Then you put within this formula n divided by df of t. So here we have only 1 by 2, and that is returning, this is the frequency, right? This is called TF, IDF, vectorization. So I hope you understood all these things. Now let's see here practically, you will better understand, friends, right? So first of all, I'm importing some important libraries here like NLTK string, then we have NumPy, then pandas. Let me execute this code. And then we talked about text preprocessing, and we said text preprocessing is the first step to transform the raw text into which is ready for computation and modeling. Now loading the text, normalization, loading the text, converting into lowercase, stripping the punctuation, and then tokenization, stemming. Let me show you here. You consider this one as a corpus for us, right? 3 sentences are there, and this one is taken from the second book. From this book, friends, applied text analysis with Python. So the example is taken from there. These are the 3 sentences. And now first step here, what we are applying, preprocessing. I will be reading the text, right? First I am creating the object for this lemmatization, and then I am converting all the text into lowercase, and one by one they will be tokenized. So the text, the sentences one by one will be tokenized, right? And then within the tokens we will be seeing whether the text or the token is there within this punctuation or not. If it is there, you just pass, you ignore that. For example, if period is there like this, you ignore that. If question mark is there, you ignore that. If the slash is there, you ignore that. And the remaining, if there is not those things, you just lemmatize them, right? I'm calling the function. This is my lemmatizer object here, and through that I'm calling the function limitizer, that will be limitized and converted into root. Let me execute this part. Yeah, it is executed. Now let's see here. I am calling the function normalize. This is the function, right? And passing the corpus with 3 sentences. Now let's see here the result, whether it is converted into tokens. Yeah, they are converted into tokens, friends. You see, they are all converted into lowercase. Question marks are removed. If period was there, that is removed. They are all tokenized, limitized. All those operations are performed, right? And at the same time it is sorted, because here I have called the function sorted. They are sorted like this, right? And now here, text vectorization and transformation. So as I said, the text cannot be directly applied to modeling, because models or algorithms, they need quantitative values, not qualitative values. First of all, we have to convert them into numeric data or numbers. So for that, different types of operations are there for converting them. So the first type is called bag of words. So what is this bag of words? Is used to extract features for a text or corpus that can be used in machine learning, right? Extracting the features from. Now it represents every document from the corpus as a vector whose length is equal to the vocabulary of the corpus. Here we have this document, this is the second document, and this is the third document, and this one is the vocabulary, the whole, and each word is repeated. But you have to remember, the document is the union of these documents, right? This one, sorry, the vocabulary is the union of repeated words will not be there, but the words will be here, right? And then tokens are positioned in alphabetical order. You see here the tokens are already ordered as we sorted there. They are already ordered, right? And then what do we have? We can keep a dictionary that maps the tokens to the vector position. So here these are the documents and this is the vocabulary, and there we will be keeping a dictionary for mapping these documents, the words with their meaning, or for example here the values. What do we have here in dictionary? Now we will be implementing vectorization using NLTK. There are different methods are there for implementing. Friends, will be using NLTK here and scikit-learn, and we will consider the following 3 types of vectorization as we discussed earlier: frequency vectorization, one-hot vectorization, and here we have term frequency and verse document frequency. Now let's see one by one frequency vectorization. And frequency vectorization, as we said here, you see the example, at is not there, so it is 0, but is repeated 2 times, so it is 2. How many times it frequency, right? Simplest vector encoding model is to simply fill in the vector with the frequency of each word, how many times a word is repeated. So here it is saying but is 2 times repeated, can is repeated once, and here C is repeated 2 times. This is called frequency vectorization. In NLTK, if you are using that, we have to manually and define a function for that. We will be using from collection here default dictionary, and I am creating a function called vectorize and passing the document, and then the text will be normalized. I am calling the function here, you see, normalization will be applied, and then if it is there, you just increment the number. If it is already there, for example 8 is there, second time if it is coming, then it will be 2 times, 3 times, it will be counting that, right? Let me execute this part here, and then you see here the article that is repeated 5 times, elephant, this one is repeated once, this is repeated once, and this one is repeated 2 times, and bat is repeated 2 times. And this is frequency of each term, right? And that is called frequency vectorization. If you are using scikit-learn, friends, and there we have something, this one we will be calling the function. This module we will be using count vectorizer. So I create another function called vectorization, and then I instantiate this vectorization. I say vectorizer, and then I'm converting the document into lowercase, normalize them. I'm calling my normalization function, so the text is normalized, and then I will be calling this vectorize, then fit transform, right? In the result, I'm converting into data frame. Let me execute it here, and let's see here the result. Here we have at 1, this one 2 times, it is, you see here, in this one is 5 times here, right? 5 times it is repeated. So instead of this creating data frame, you directly can use this one also, friends. It means I'm zipping here the feature names, what was the feature, and here how many times that was repeated, right? And this is used for converting into one dimensional, the function I'm calling from numpy array, right? And then let us see here how that returns the values. You see here, sorry, I have to execute first this and then this. Okay, sneeze is repeat only once, C is repeated 2 times, and then what do we have here? Yeah, done article, it is repeated 5 times. If you are using data frame, so that will be in the form of table, and you will be getting this one. Yeah, you see here, these are the outputs. So I hope you understood these things, friends. Now let's see one hot encoding or vectorization. In one hot, as we discussed, if the word is there, so it will be 1. If it is not there, it will be 0. So see here, at is there, it is 1, but is not there, so it is 0, this one is 0, this one is 0. Elephant is there in this document, it is 1. Off is there, it is 1. So like that it will be considered 0, 1 binary values, what we call it as a Boolean. So using NLTK, so in NLTK, what do we have to do? NLTK implementation of one hot encoding is a dictionary whose keys or tokens and values are true and false. Here I will be creating, the function is returning a dictionary, right? What is here? The keys, we have the tokens, the values are this one 0, 1, but I am returning only 1 because zeros we don't need that. We only return, the function returns only once if it is there. You see, the words are there, they are returning once. And then if you're using scikit-learn, right? In scikit-learn, what do we have? Here we will be using another module called binarizer. This binarizer will be used, but before that we have to use vectorizer also. They all should be first vectorized, and then the vectorized data will be fed to this one binarizer object, and then it will be converted into that form or one hot. So this is the function I'm using, vectorization, scikit-learn dot preprocessing, and from there binarizer, and then I'm instantiating count vectorizer. I'm normalizing the text, right? I'm calling my function normalize. It means this function I'm calling this function, friends, right? So the text is normalized here, right? Yeah, that is normalized, and then it is converted into, it is transformed into numbers, right? Frequency is found, and then I'm instantiating my binarizer, and one hot code dot, I'm calling this function fit transform, that will be converted into binary form. It means 0, 1. Let's see here the result, you will better understand. So this is the vector. What do we have, friends? So in the whole document, this word is repeated here once, so the remaining everything will be considered as 0. Again, the second word, in which position it is on, so it is true in this position. The third word, it is true in this position. The fourth word, which is considered or token, is it is true in first position, and like that. See, no word is repeated, and this is the result 0, 1, 0, 1. And this one you have to know, this is array, we are converting them into array. It is optional, so you can remove it also. So you will be having like this. Instead of that, you can use here dense also. This dense is converting into too dense, you have to use here, sorry. Now, right, so it is converted into one hot coding. And then lastly we talked about this one, TF-IDF vectorization. So we have term frequency, document frequency, and then we have inverse document frequency, and this is inverse document frequency we already discussed. Here you see it will be counting like this is the frequency, right, IDF for each and every word. It will be in this form because we have log here, right, log base 10 n divided by, this is total number of documents, and this one is document frequency of each term, how many times the term or the key is repeated in the same document, in whole documents, and also in whole corpus, that will be considered. So using NLTK I will be creating an object of this one, right, text collection. Here I am creating a function called the vectorizer. The corpus is passed, and here it is converted into text collection, and then here I am calling this function, see, TF-IDF, and that will be converting the words like this. A simple example I give here. This is a simple. The man took the book. Since it is only one document is there, right? It is a single document. So how many times this one is repeated in the same document, this one is repeated, and based on this formula, n divided by this formula, it will be calculated, and it is all returning these fractions for us, right? These numbers, float numbers. And instead of this, you can pass the corpus, right? And then here you can one by one the document also you can read. Now if you are using scikit-learn here, then in scikit-learn what we have to do, we will be calling, creating an object of this one, instantiating this one, see, TF-IDF vectorizer, right? So vectorization, the document comes here. If you want to normalize it, so you can apply normalization also. Then what do we have here? We have, I'm creating an object of this one, TF-IDF vectorizer is equal to TF-IDF vectorizer instantiation, and then okay, document term, here we have document term matrix is equal to, I'm calling this function fit transform, and then it will be returning a dictionary for us. Now let's see here. Yeah, see, at later is there, it is there, right, in the first document. So this is the first document, this is the second document, this is the the third document in the whole corpus. 3 documents we have. So this is the frequency of at in this sentence, and then across the whole corpus. But was not there because it is not there in the first sentence, right? You consider it as a first document. So buts, this one is not there, this one is not there, this one is not there, but elephant is there, right? It is here, right? It is here. Yeah, elephant is here. So this is the frequency for that, TF-IDF frequency. How many times it is repeated in the same document, how many times it is repeated in any documents, and then that IDF of that. Then off is there, this is the frequency for that. Open is not there. Friends, it is not the same words, because I have not applied normalization here. If you apply normalization, so these two will be considered as one. This will be lemmatized, and then see here, opened will be converted into open, potatoes into potato, because we are steaming the words there in normalization. So I hope you understood all these things, friends. This is called, okay, TF-IDF vectorization, and this one is this is using scikit-learn, and this one is using NLTK. In here also, this one is using scikit-learn, and this one is using NLTK. Again here the same I have used here for frequency vectorization, also NLTK and scikit-learn. So I hope you understood all these things. These were the steps we followed in text normalization, loading the text, converting into lowercase. Here they are all converted into lowercase, then tokenized, and here we strip the punctuations, and then we applied lemmatization. So these were the topics what we promised, and I hope you understood all the things. Thanks, friends.